Good evening dear students, welcome back to second PUC online classes. In today's class we are discussing about the spectral series of an hydrogen atom. Spectral series of a hydrogen atom. It means when an hydrogen gas is heated, the electron go to different excited states depending upon the amount of thermal energy received by each electron. For example, suppose we have to consider one hydrogen gas. Okay, that hydrogen gas is heated, okay, and these electron absorb that energy and it jumps from one state to higher state. That electron jumps from ground state to higher excited state. This one called as ground state and this one is called as excited state. That electron jumps from one state to another state, and when it returns back to excited state to metastable state or ground state, it emits radiation, it emits energy. It is in the form of electromagnetic radiation, okay, and due to that one spectral series will be forms. When electron jumps from higher state to lower state, at that time it forms a 5 spectral series, that is called as Lyman series, Balmer series, Paschen series, Brackett series and Fermi series. Okay, now we are discussing one by one. First, this one is a very important for 5 marks. Write a note on spectral series of an hydrogen atom. Write a note on spectral series of an hydrogen atom. Explanation: when hydrogen gas is heated, when hydrogen gas is heated, the electron go to different excited state. The electron go to different excited states, depending upon the amount of thermal energy received by each electron, full stop. When they returns to the lower energy states, to the lower energy states, when they returns to the lower energy states, they emits energy in the form of electromagnetic radiation. Electromagnetic radiation gives rise to several spectral series. That wavelength of different orbit where calculated by using the empirical formula 1 divided by lambda is equal to r into 1 divided by n1 square minus 1 divided by n2 square. Okay. Wavelength of radiations emitted by the electron when it jumps from higher orbit to lower orbit. Higher orbit to lower orbit is calculated by using higher orbit is calculated by using 1 divided by lambda is equal to r into 1 divided by n1 square minus 1 divided by n2 square. Okay, n2 square, where r is called as Rydberg constant. R is called as Rydberg constant. Rydberg constant, its value 1.097 into 10 to the power of 7 per meter. Now discuss one by one 5 spectral series. Following are the spectral series formed by an hydrogen atom. Following are the spectral series formed in hydrogen atom. Number first one, that is the Lyman series. Here electron jumps from higher orbit to the first orbit. When electron jumps from higher orbit to the first orbit, at that time this series will be formed. Okay, this series is obtained due to the transition of an electron from higher orbits to the first orbit, higher orbit to the first orbit, that is from n2 is equal to 2, 3, 4 dash dash to n1 is equal to 1. Here electron transition occurs from higher orbit to the first orbit is called as Lyman series. Okay, electron transition occurs from higher orbit to first orbit. N1 is equal to 1. Okay, these are the higher orbit. Here electron transition occurs from higher orbit to the first orbit. Okay, this one you call as which series? Lyman series. And second one. Okay, and this series lies in which region? It observed in ultraviolet region, UV region. This one is observed in which region? UV region, ultraviolet region. Okay, this spectral series is observed in ultraviolet region. And second one is the Balmer series. Okay, this series is obtained due to is obtained due to the transition of an electron from higher orbits to the second orbit. Transition of electron from higher orbit to the second orbit. Okay, that is from n2 is equal to 3, 4, 5 to n1 is equal to 2. Here transition of electron, this one is a n1 is equal to 2. Electron transition occurs from higher orbit to second orbit. Okay, this one you call as Balmer series, and this one series observed in which region? This one series is observed in which region? Visible region. Observed in a visible region. This one series observed in visible region. Okay, and next one is the third one. Paschen series. Okay, here electron transition occurs from higher orbit to the third orbit. When electron jumps from higher orbit to the third orbit, at that time Paschen series will be obtained. And this one is observed in a infrared region. This series is obtained due to the transition of an electron from higher orbits to the third orbit. That is from n2 is equal to 4, 5, 6 to the n1 is equal to 3. Electron transition occurs from n1 is equal to 3 higher orbits to the third orbit. Okay, this one you call as which series? Paschen series. And this one is observed in which region? Okay, this one is observed in a infrared region. IR region. Next, fourth one, bracket series. This series is obtained due to an electron transition occurs from higher orbit to the fourth orbit. This series is obtained due to the transition of an electron from higher orbits to the fourth orbit. Higher orbits to the fourth orbit. Transition of electron from higher orbit to the fourth orbit. That is n2 is equal to 5, 6, 7 to N1 is equal to 4. Okay, here electron transition occurs from higher orbits to the fourth orbit. Electron jumps from higher orbit to the fourth orbit. This one we call as bracket series. And this one also observed in which region? IR region. This one also observed in IR region. And last one is the fifth one, fund series. Fund series. Okay, this series is obtained due to the transition of an electron from higher orbits to the fifth orbit. Higher orbits to the fifth orbit. Transition of electron from higher orbits to the fifth orbit. That is N2 is equal to 6, 7, 8 dash 2 N1 is equal to 5. And this one is observed in which region? This one is observed in IR region. This one also observed in IR region. Okay, students, up to year 5 spectral series explanation over. In tomorrow class, discussing about the energy level diagram and the definition of excitation and excitation energy, ionization and ionization energy, and one more concept left, that is the Bohr's quantization rule. Okay, thank you. Okay, after completion of this topic, we will discuss numerical problems, and after that one more new topic will be left, that is the nuclei. Okay, up to here, watch all the videos, don't neglect all the classes, and write your own notes.